Okay, so chapter 9, muscular system. We're going to go in more depth here. Types of muscle. There's 3 types: skeletal, smooth, and cardiac. So skeletal muscle is generally attached to bone. It is voluntary muscle. The muscle appears striped or striated. It produces movement, maintains body posture, and stabilizes joints. They produce considerable heat, and if damaged, the muscle has limited capacity for regeneration. Smooth muscle is found in the walls of the viscera, such as the stomach or the bladder, and is called visceral muscle. Also found in bronchioles, involuntary, so we cannot control the movement of these muscles. Contraction has 2 unique, so smooth muscle contraction, to be specific, has 2 unique characteristics in comparison with skeletal muscle contraction. First, smooth muscle contraction is slower and continues for a longer period. This allows for a continuous partial contraction of the smooth muscle. Okay, and it says smooth muscle tone plays an important role physiologically. For example, the muscle tone of the smooth muscle in blood vessels helps maintain blood pressure. And cardiac muscle is found only in the heart, and it is also involuntary. It is stratified also, though. If damaged, as in a heart attack, it has no capacity for regeneration, unfortunately. So does smooth, I wonder? I didn't see that in here. Oh, look it. Okay, it says if injured, smooth muscle has a better capacity for regeneration than does skeletal muscle. So smooth muscle can regenerate better than cardiac or skeletal. Muscle fibers. What you are actually feeling when you feel your muscles are muscle fibers, blood vessels, nerves that are packaged together by various layers of connective tissue. A large skeletal muscle is surrounded by layers of tough connective tissue, which is called fascia. The outer layer of fascia is called the epimysium, and the layer that surrounds smaller bundles of muscle fibers is called the perimysium. So there's a picture on page 145. Think of Twizzlers. That's like each myofibril. So a tendon, when the epimysium, perimysium, and endomysium extend toward and attach to the bone, this is a tendon, a long cord-like structure. So muscles form attachments to other structures in 3 ways. 1, tendon attaches the muscle to the bone. 2, muscles attach directly without a tendon to a bone or to soft tissue. And 3, a flat sheet-like fascia called aponeurosis connects muscle to muscle or muscle to bone. Sarcoplasmic reticulum. So structure and function of a single muscle fiber. At several points, the cell membrane penetrates deep into the interior of the muscle fiber, forming transverse tubules. Within the muscle fiber is a specialized endoplasmic reticulum called the sarcoplasmic reticulum. Each muscle fiber is composed of long cylindrical structures called myofibrils, and each of these is made up of a series of contractile units called sarcomeres. Each sarcomere extends from Z-line to Z-line and is formed by a unique arrangement of contractile proteins, referred to as thin and thick filaments. So contractile proteins, these are important with the contraction of the muscle, I would assume. The thin filaments extend toward the center of the sarcomere from the Z-lines. The thin filament is composed of 2 proteins called actin and the troponin-tropomyosin complex. The actin contains binding sites for the myosin. The thicker myosin filaments sit between the thin filaments. Extending from the thick myosin filaments are structured called myosin heads. The arrangement of the thin and thick filaments of each sarcomere is what gives skeletal and cardiac muscle its striated appearance. And this sarcomere structure is important in understanding how the sliding filament works, which causes muscle contraction. And that brings us to sliding filament mechanism. Muscles can only pull, not push. So to pull, muscles contract. They shorten. Contract means shorten. So that happens because the sarcomere length shortens, and that happens when thin and thick filaments slide past each other. We're going to explain how the sarcomeres shorten. When the contractile apparatus is stimulated, the sarcomere is flooded with calcium. This enables the myosin heads to make contact with special sites on the actin, forming temporary connections called cross bridges. Once the cross bridges are formed, the myosin heads rotate, pulling the actin toward the center of the sarcomere. The rotation of the myosin heads causes the thin filaments to slide past the thick filaments. Sarcomere length shortens. Muscle relaxation occurs when the cross bridges are broken and the thin and thick filaments return to their original positions. The sarcomere lengthens. Because of this sliding activity of the thin and thick filaments, muscle contraction is called the sliding filament mechanism of muscle contraction. The sliding is like a trombone. They slide, okay? Calcium and adenosine triphosphate, ATP, play important roles in contraction and relaxation. Calcium is necessary for the formation of the actin-myosin connections, called cross bridges. Calcium is stored in the sarcoplasmic reticulum, away from the thin and thick filaments. When the membrane is stimulated, calcium is released from the SR and floods the sarcomere. The calcium exposes a site on the actin that is necessary for the binding of the myosin heads, the formation of cross bridges, and sarcomere shortening. When calcium is pumped back into the SR, the cross bridges are broken and the muscle relaxes. The energy released by ATP is necessary for cross bridges to both form and disengage. Okay, that's like my least favorite stuff to read about. Watch a video, it'll help. Skeletal muscle, okay. So contraction can only take place when the muscle is first stimulated by a nerve. So motor nerve, composed of many nerve cells called motor neurons, emerges from the spinal cord and travels to the skeletal muscle. Motor nerve, composed of many nerve cells called motor neurons, emerge from the spinal cord and travel to the skeletal muscle. The interaction of the motor neuron and the muscle is described in terms of the motor unit and neuromuscular junction. Motor unit. Motor unit consists of a single motor neuron and the muscle fibers that are supplied by the motor neuron. Okay, so as a motor neuron approaches the skeletal muscle, it forms many branches. Each branch, so think of like a tree, let's be visual. So motor neuron approaches, this cell is approaching the skeletal muscle, it forms many branches. Each branch innervates a single muscle fiber. Okay. So each muscle is innervated by many motor neurons, thereby forming many motor units. The strength of muscle contraction can vary depending on the number of motor units that are stimulated. The neuromuscular junction. The area where the motor neuron meets the muscle is called the neuromuscular junction, NMJ. So it includes the membrane at the end of the neuron, the space between the neuron, and the muscle. So there's that picture on 149. It's that whole area. I think a video would explain that better. Okay, I'm going to skip over that. Disorders of the neuromuscular junction. There's myasthenia gravis. It's a disease that affects the neuromuscular junction. The symptoms of this disease are caused by damaged receptor sites on the muscle membrane. The receptor sites are altered so that they cannot effectively bind ACH. Consequently, muscle contraction is impaired and there's extreme muscle weakness experienced. And this disease, as it progresses, does more than just affect our muscles of our appendicular skeletal system. So your breathing would then be affected. And then neuromuscular blockade caused by Curar. I thought this was interesting. That's a drug that they used to use when hunting for animals that they would dip. It's a paralyzing drug that was dipped, the tip of the arrowhead was dipped in Curar. And so that is a skeletal muscle blocker, and it's often used during surgery now to promote muscle relaxation and paralysis. So it works by blocking the receptor sites on the muscle membrane. Because these receptors are occupied by the drug, ACH cannot bind, and the receptor sites and muscle contraction is prevented. So in this, since you're temporarily paralyzed, your respiratory muscles are also, so you have to be mechanically ventilated until the effects of the drug wear off. Effects of neurotoxins on muscle function. Neurotoxins are chemical substances that in some way disrupt the normal function of the nervous system. Neurotoxins are produced by certain bacteria, for example, Clostridium tetani, a bacterium that causes excessive firing of the motor nerves. This in turn causes excessive release of ACH, overstimulation of muscle membrane, and causes severe muscle spasm and tetanic contractions, hence the name tetanus, like lockjaw. A second neurotoxin secreted by the bacterium Clostridium botulinum. This appears when food has been improperly canned, and it causes botulism. So the neurotoxin works by preventing the release of ACH from the ends of the neurons with the NMJ. So since the muscles cannot contract, the muscle and the breathing muscles become paralyzed. Although this sounds bad, it is used in small amounts as Botox, and has also been used to treat severe muscle spasm like torticollis and cerebral palsy and migraine headaches. Oh, wow. So they relax the wrinkle lines, because that's from contraction of that muscle over and over. Interesting. And so twitch and tetanus. If a single electrical stimulus is delivered to a muscle fiber, the fiber contracts and then fully relaxes, and that's called a twitch. But sustained muscle contraction is called tetanus, which is very important in maintaining posture. And if we didn't have that, then we'd be it'd be really weird, twitching all over the place, just stand up. Recruitment. As described previously, recruitment of additional motor units increases the contractile force of a muscle. Recruitment is characteristic of the whole muscle, not a single muscle fiber. Muscle tone, or tonus, refers to a normal continuous state of partial muscle contraction. To maintain muscle tone, one group of muscle fibers contracts first. As these fibers begin to relax, a second group contracts. This pattern of contraction and relaxation continues to maintain muscle tone.
No, these aren't candies, these are bees.
So, for example, the tone of the skeletal muscles in the back of the neck prevents the head from falling forward.
I'll need to grease the bowl with oil.
You must be halfway through because I'm checking. Yep. Pretty much. much. Okay, energy source for muscle contraction is ATP. I'm not going to really go into that so much. Origin and insertion refer to the sites of muscle attachment. So specifically, origin of the muscle attaches to the stationary bone, whereas the insertion attaches to the more movable bone. Hypertrophy is overused, muscle increase in size. Atrophy, there's different types, but this is when muscles are wasting away and decreasing in size. So skeletal muscles are named by size, shape, orientation of fibers, location, number of origins, origin and insertion, and muscle action. So facial muscles, there's the frontalis, which covers the frontal bone. That's the front of the head, easy to remember. There's the temporalis, which would be on the side. Is there like the... Oh, no, I guess not. Okay, then there's orbicularis oculi, circular muscles around the eye. Levator palabre superioris is... That freaking sounds like something from Harry Potter. Levator. So it's the muscle that allows you to open your eyelids. Orbicularis oris, those are the kissing muscles. You encircle the mouth. Buccinator are the ones important for like sucking, like for babies. So horizontal cheek muscle. Zygomaticus, origin on cheekbone. That's the smiling muscle. Platysma, this is the one that's on the neck, and when it weakens as you age, that gives you that turkey neck. There are so many muscles, I'm not going to go through all those. Okay, sternocleidomastoid, that's that neck muscle that allows you to like look from side to side, that big muscle that comes out. Trapezius are the ones like in the back of the neck, base of the occipital bone, allow you to tilt your head back for hyperextension. Muscles involved in breathing, intercostal muscles and the diaphragm. There's 4 abdominal muscles, rectus abdominis. Those are the vertical ones. External oblique are slanted. Internal oblique are also slanted, and they cross over the external and create a crisscross pattern. Transversus abdominis are horizontal. Come on, I'll help you. Muscles of the shoulder, trapezius, serratus anterior, located on the sides of the chest. Pectoralis major, latissimus dorsi, deltoid, teres major, long round muscle that has its origin on the scapula and inserts on the humerus. Rotator cuff muscles, there's 4 there. The subscapularis, supraspinatus, infraspinatus, and teres minor. Carpal tunnel, we all know what that is.
Sam, I don't know what else to do. Guys, maybe you know what to do to fall asleep.
Okay, so then the little pictures at the very end. So kissing muscle is orbicularis oris. The trumpeter's muscle is buccinator. Hamstrings, praying muscle is sternocleidomastoid. Toe dancer's muscles, gastrocnemius and soleus. Smiling muscles, zygomaticus. Taylor's muscles is sartorius because they used to have to sit in the lotus position, like crossing their legs to fix clothes. Swimmer's muscle, latissimus dorsi, Achilles tendon, and When you're surprised, oh my, that is you using your frontalis muscle. And that's it.